Hi, welcome to Digital Electronic. Today I would like to talk about Karnaugh map approach, also known as K-map. So this is under chapter 3, basic and combinational logic circuit. So we have go through lots of things before we arrive to the K-map approach, which is 3.6. So in the previous class, I already covered the basic gates, and this is the summary. So for the non-gates, for the other gates, which is AND gate, NAND gate, OR gate, NOR gate, XOR gate, and XNOR gate. Also mention about the combination logic circuit. Usually we can express any Boolean expression from this any combination circuit logic circuits. So we have a circuits and we can get the Boolean expression. So from the Boolean expression we can also have the truth table. And I also mentioned in previous class the Boolean expression that we have can be very complex and repetitive. That's why we need to simplify it to reduce the number of gates and operation time. So one of the method is to use simplification using Boolean theorem. So we have a Boolean expression, we use all the rules, and we get the, even though we get able to get to simplify this expression using Boolean theorem, there are high possibility that using this mathematical approach are not that simplified, so that therefore we need any alternative approach just to check and balance on, to check whether we have a correct simplified version or we need further up to simplify. So therefore that's why we need this K-map. Is an excellent tool to know all the possible or simplified Boolean expression. So there are four main steps in the K-map. So for the first step, you have to map the truth table output from in the K-map. So you're going to have a K-map like this. So you have for this one, for example, this is a 3-input K-map. So you have a A and B over here, and you have a third input C over here. And because you have B and A and B two inputs, so you're going to have a four possible condition, which is 0 0 0 1 1 1 0 1 0 and 1 1. So be careful over here, because usually we write 0 0 0 1 1 0, but the 1 0 should be at the bottom here and 1 1 over here. Please write in order like this, so that to avoid any problem in the future. For the C input, you have a possible only two possible input, whether you are in C bar or C, that means 0 or 1. Steps 2 will involve grouping 1, so the bigger the better. Steps 3 will determine the minimum product term for each group, and step 4 to sum it up. So don't worry, I will go through one step by step and explain all the rules involved until you get the step number 4. For example, over here you have a Boolean expression, a big Boolean expression. So from here you can put it on. For example, a dot b dot c is actually a dot b dot c. So you have 1 1, so you have 1 1 over here, and c is also 1, so you have 1 over here. So you just need to put over here, and so on until you finish, and then you get when you simplify this particular version, you got z equals to a, and this one is similar to the page number 5, which is also, so instead of doing lots of I'm not saying that it's not good, the mathematical approach, but instead of doing lots of steps, you also can use the K-map to get the answer. So let's begin by approaching the first step. So first step will be the mapping. So mapping the K-map. So when you have a truth table of 3 inputs, so you have input A, input B, input C. So there will be 3 input will have 8 possible configuration. So that means you have 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 101, 110, and 111. So each of these, you can write it up expression as like this. For example, 000, you always can write a bar dot b bar dot c bar. And for example, 011, you can write a bar dot b dot c. So for each of the input, the possible, you're going to have output. So for example, output number first for the 000, this I write it over here as 0. 001, I write it at number 1, and so on until 7. So you have how to map it. During map, first before you map, you need to get your raw K-map correctly. So you need to put your, for example, if you want to do the vertical type, so you're going to have such a condition. If you want to have the horizontal type, you're going to have this situation. So for example, so you have a vertical type, so you have A and B over here and C over here. So 0, 0, 0, 1, 1, 0, and 1, 1, and 0, 1. So you just put over here. So your 0, 0, 0, which is A bar, B bar, C bar. So A bar is here, B bar is here, and C bar is here. So this will be your number 1, the first one, the 0. The second one, you have 0, 0, 1, which is A bar, B bar, C. So A bar, so you have a A bar over here. B bar, you have a B bar over here, and you have a C, so it's C over here. So that's why I have plotted here number 1. So I follow whatever output over here, you have to map over here, right? So for the third one, A bar, B, C bar, so you get number 2. So A bar, B, C bar, so you have number 2 over here. A bar, B, C, A bar, B, C. That's why you have number 3 over here. A, B bar, C bar. A, B bar, C bar. That's why you have number 4. A, B bar, C. A, B bar, C. You have number 5. A, B, C bar. A, B, C bar, number 6. And A, B, C. A, B, C. So that's why you have number 7 over here. So please be careful. It's always written 0, 1, 2, 3, 4, 5, 6, and 7. So this is like a change of place over here. So be careful over here, this one. So if you want to go for the horizontal type, so you have A over here and B and C over there. So A will have a response of A bar and A. B, C will have 0, 0, 0, 1, 1, 0, and 1, 1. So how to arrange in a such a way? You have to arrange 0, 1, 2, 3. You finish up the first row, and then 4, 5, 6, and 7. So be careful on this part. So this is for 4 input truth table. So you have a 0, 0, 0, 0 because you have 4 inputs. 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, and so on until you have 1, 1, 1, 1. So for the output, you have to start with 0 until you have 15. So how are you going to arrange this one? So this one is when you have a 0, A is equals to 0 is a A bar, B equals to 0 is B bar, C equals to 0 is C bar, and D equals to 0 is D bar. So you're going to have A bar, B bar, C bar, and D bar. That's why you have the first output 0 over here. Second one, 0, 0, 0, 1. So you're going to have A bar, B bar, C bar, and D is 1, so that's why you have 1 over here. So that's why you have a 1 over here. So the arrangement is 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and 15. So be careful on this side and also this side. The middle stage is quite little different. So another story on this one, we already discussed the truth table for 3 input and 4 input. How about if it came with the non-standard SOP, which is from the Boolean expression? So from the Boolean expression, how are you going to map it out? So you have a condition z equals to b bar dot c bar plus a dot b bar plus a dot b dot c bar and a. So if you see over here, this is missing of a and a bar. Over here, it is missing the c and c bar. Over here, have 3 inputs, so it's okay. And over here, a is missing the b and c. So for this particular, let's go one by one. So you have a B bar and C bar. So it's missing A. So you're going to have 2 possible. Either it can be A or it can be A bar. So we have to write both of it. So that's why the first one you have A dot B bar dot C bar. And second possible is A bar dot B bar dot C bar. Right? So don't if you that's why you have 2 possible. When the A is missing because of the simplification, you need to have 2 possibility. There is A and A bar. For this part, you are missing the C. So if you see over here, A B bar dot C, A B bar dot C bar. So that's why you have a 2 possibility, and this is okay, no need to worry much. But A, you have missing the B and C, so we have to have two situation for B, which is B and B bar, and for C you have 2 situations, C and C bar. So that's why you have the first one A dot B bar dot C bar, the second one A dot B bar dot C, the third one A B C bar, and the last one A dot B dot C. So if having all this situation, so the next step is we have to map, because this is a 3 input. You have A, we have B, and we have C. We don't have D. So this is a 3 input. So that's why I am prefer on the vertical type. So this is more convenient for me. So I would like to use this one instead of the horizontal type. So you can use anything you want, but I prefer to use vertical. It's much easier for me, and I suggest you to do that. In my example, we focusing on the vertical type. Right, so when you have all the possibility, so you have to write the first one, A, B bar, C bar. So you write this one, Z equals to this one. And the second one here. The third one here. The fourth one will be here. Fifth one here. 6, 7, 8, and 9. So when you have this one, you have to dash out the repetition, because anything times with anything, you get the same thing. So that's why when you have a repetition, for example, A dot B bar dot C bar, you have a repetition here again. So you just dash it out one and take it out everything. So when you eliminate all the repetition, you're going to have 1, 2, 3, 4, and 5. So here now you just rearrange into the situation. For example, A dot B bar dot C bar. So A dot B bar, A dot B bar dot C bar. So you have 1 over here. The second one will go over here. So A bar dot B bar C bar. So you have 1 over here. A B bar C. So A B bar C you have over here, and so on until you finish everything. So you have a 5 inputs. So check again, 1 2 3 4 5. 1 2 1 2 3 4 5. You have a 5 inputs, and other than this you need to put 0 because this is a SOP, so you just have to sum of products, so you have to put zeros over here, which it is not included. Then you need to map it, group it into one. So for example, the bigger group you can form here, 1 2 3 4. So you have 4, you have to group over here. And don't forget, you have one over here, you have one over here, so this is a adjunct, so you need to take consideration on this one, and then you simplify, you get this one. So for example, the big group a dot b and a dot b bar, so b and b bar you can take it out, so it become a, and C and C bar, so that's why it become this one, the response is A, and this one the response is B bar dot C bar. So I will discuss more detail later on in the coming examples in the next future pages, so don't worry about this, how you get to get them, the grouping. Rule number 2. And the simplification have cost us a lesser operation gates if used. For example, you need lots of gates over here. So for example, each of the situation input you need one gate, so you have lots, but over here you only less gates, you only need 5 gates to perform this task. Okay, step 2, the rule is to map the K-map. So, and you need to understand how is adjoint concept. So for example, when you have a 4 input K-map, each of the tiles are connected each other. So for example, when you choose a tiles, this tile, so on your left, on your bottom, on your top, on your right, on your bottom, all of these are connected each other. For the second one, if you have still 4 inputs, so anything that is over left, on the left, is actually is wrapped up concept to have a connection with the right side of the, so it's a wrap around concept. And for the top version and the bottom version is actually is connected to each other from top to bottom or bottom to top, and is a concept of a wrap around concept. So step 2, B, how to map the K-map. So the one grouping rule. So you have 3 rules to be take care of this, to map one, to have the maximum one. First, you need to know the one can be in either 1 or 2 cells, 4 cells, 8 cells, or the most unique one, the 16 cells. So for example, when you have 2 cells are connected to each other, so you can have a possibility of like this, 2 is going like this, or maybe 2 like this. And don't worry, don't forget, so like I mentioned, it's a wrap concept, a wrap around concept. So you have one over here and another one over here, so it's a wrap around, so one and another one over here. So this is the example of 2 cells are connecting each other. And how about the four cell? So you also have 1 2 3 4, so this is a bigger group, so you have 0 0 0, everything is like, it's like a mine, so you have 1 1 1 1. So you have one over here, one over here, don't forget the one over here and one over here, so this is also connected to each other. And you also can have a vertical type of 1 1 1 1 1. So here is 0 0, so that's why you don't have a connection from here to here, and you have a connection just all like this. And rule number 2, you must adjoint each cell and form the largest possible group. And don't forget, rule number 3 is also says that there is a possible of overlapping situation. For example, this is overlapping, this is also overlapping situation. So you have this is an example of 8 cells. So you, for 8 cells is very unique. you only can have a situation where it is in the middle, either vertical or horizontal 8 cell together. Or maybe you can also have a right side. Yeah, my bad. So when you understand how to group the one, so we need to understand what is the possible of output they can have. So step number 3, to have the minimum SOP for the CAMAP. So when you have a CAMAP like this, there is a lots of possible grouping method. So when you have a group of, for example, the red color, a group of one cell, so only one cell over here, you are not connecting to the top one or bottom one or left or right, anything. So you're stand alone. For example, my bad, is not yeah, maybe later I will show you. You only stand alone like this, so only one. So in for only one group, you're going to have one cell only produce for 4 variable product. For example, over here, so you have A bar, B, C, and C, D bar. So that's why you have something plus A dot B bar dot C dot D bar. So we go for the second group of two cells. If you have a two cells are connected each other, like a previous one, you have a two over here. So usually it produce 3 variables output. So for example, you have A bar, B bar. So you have A bar and B bar. And for this one, you have C. So both of you have a C. And because D is D and D bar, so this can be eliminated. So that's why you have A bar, B bar, and C. A bar, B bar, and C. So the third one, group of 4 cells. So you have 4, 1, 2, 3, 4. And for this one, you need to produce only, you are only able to have 2 variables. For example, this one, A bar A. So this one is eliminated, but you have B. So B and B. So you have B. This one you have C bar C. So you can eliminate C, and D you just keep D. That's why you have B D. Okay, my bad. This is B. So you have B and D. This is dot. Okay, for the fourth one, a group of 8 cells only produce 1 variable product. So you have this one, A bar and A, so you can eliminate. B, you have B, both of B, okay, just preserve. And C, because 1, 2, 3, 4, you have C bar, C bar, you have a C and C, so you can eliminate this one. You have D bar, D, D, D bar, so you can eliminate this one. So C and D you can eliminate as well as A, so that's why you only have a B over here. So yeah, this is a B. And for the 16 cell, because everything is connected to each other in any kind of way, so it's only produce 1 as an output. That's why you have equals to 1. So the step 4, to mapping the K-map, sum all the products to form the minimum SOP. So when you need to, so for example, we have a situation, this one 2 cell, this one 4 cell, and this one is 8 cell. So the green one will produce A bar, B can be eliminated, and C, D bar. So A bar, and then you can have a B over here. So this one is this one is A, B, A bar. So this one is A actually, and this one is C bar, C. You can eliminate D is D. So you have A and D. And the last one, you have the B, A bar, A, you can eliminate. So B you have to take, and everything become B over here. So you add it up. So you're going to have uh, this one, it become A, this one become A, and this one become B. So at the end, you're going to have A bar dot C dot D bar plus A dot D dot plus B. Let's go for the example. Example 3, you have to obtain the simplest Boolean expression from this particular Boolean expression and try to map it out inside the K-map. So this is the Boolean expression, so you just take it out, Boolean theorem, so Boolean expression, so you just take it out. So A bar, B bar, C bar, D. So this is the K-map, so you can draw. So just put in everything inside. So A bar, B bar, C bar, D. So we just take it out over here and put it over here. So A bar, B bar, C bar, D. So you get a 1 over here. The second one, A bar, B bar, C, D. So you just follow the trail. So you have A bar, B bar, C, and D. So you have 1 over here. The third one, A bar, B, C bar, D. So you have A bar, B, C bar, D, and the fourth one, A bar, B, C, and D. So over here, you take out over here A bar, B, C, and D, and you finish up everything until the last one, A, B bar, C, D. So you just follow this one, A, B bar, C, and D. So you have this one. So when you already completed the number 1, please write the without any response as 0. So just put 0, 0, 0, 0, 0, 0, 0, 0, and 0. Next, you have to group it because this is 1. So this you can form a big, the blue color, you can form one big chunk of ones because there is 4 cells over there. And then you also have one over here, so you can jump from top and bottom. And also the green one is 1 you can form a group over here. So you have one group, top and bottom, the blue one and the green one. So you just map it. So this one is the blue color is A bar, and B you can eliminate, C you can eliminate, and D. So A bar dot D. The green one is, because it's a 2 input, you 2 cells, so you're going to have 3 variable. So you have A bar, B, so A bar and B, and D, because D and D bar, so you can eliminate, but you have to keep the C, so you have C. So A bar dot B dot C. And for the orange color, you're going to have over here and top. So you're going to have, so here and here, A and A bar you can eliminate, B bar you need to keep, C and C bar you can eliminate, D you need to keep. That's why you have B bar dot D. So the final answer, you need to add it up, this one, and this one to form this one. That's why your final answer, you have A bar dot D plus A bar BC plus B bar D. So another example, this one you need to map. If you have a truth table, let's say you have a truth table and you need to map it out. So you need to put, when you have an input A, B, C, D, you straightly know it should be in 4 input data. And over here, you need to put it out each of the results. So 0, 0, 0, 0. So A bar, B bar, C bar, D bar. So you have 1 over here, you put a 1 over here. So if you remember the previously, if you can remember the steps to how to locate all the numbers from 0 to 15, if you remember this, you can follow the steps, or if you can't remember this at particular point, so you need to follow one by one. 0001, a bar, b bar, c bar, d, a bar, b bar, c bar, d. So this is 0, so you need to put 0, and so on. And then later on group it. So you have there is a, because 1 1 1 1, so you have formed the orange connection grouping of 1. You have one group, the second group will be the blue color, and you also the green color. So you have three possible answer, and when you have these three possible groups, and when you have these particular groups, you can add it up to form the SOP of this particular K-map. So the another example will be if you have only the circuit. So this is also similar to the previous one. So when you have a circuit, a combinational circuit, so you have to come out with the standard Boolean expression of Z first. So from here, so the first one will be A, B, C, D, A bar, B, C, D. So A bar, B, C, D. And then you're going to have A, B, C bar, D, A, B, C bar, D. You have A, B bar, you have A, B bar, and A, B bar, C bar. So you have, so this one you can refer to my previous examples, example 2. So yeah, how are you going to handle if you are missing of certain input? For example, this one, A dot B bar, you're missing C, so you have to handle this one. And then you can refer the example 2 for help. And then when you already have this, map it inside this particular K-map, and then group it up, and you got the minimum SOP of this answer. And you need to redraw the simplification circuit. So instead of having such a very big circuit, you can simplify just using 3 gates, and you get the same output of here. So check 1, so you can obtain the SOP using the K-map method. So number 1, number 2. The number 3, little challenging because the circuit, you can have a look. And number 4 is the truth table, using the truth table. Please use the previous example I have go through. So another condition that you need to understand is the don't care condition. Why we need this? When you design a system, sometimes there are not all inputs are available. So to ignore that particular situation, or maybe sometimes you don't need the information before you make a decision, so you can put a don't care condition. You don't care whether it is 0 or 1, but you need to form the design. You have to make the design, so that's why you put a X over here to, instead of, it's a don't care. So for example, over here is a don't care to ease up your design so that you don't become. So when you have don't care situation, it highly depends on the situation, so please be careful on that. So for example, let's say you have a truth table, and when you have an inputs, you have a don't care situation over here, so be careful. Then when you mapping up in the K map, so you're going to have X over here and X over here. So when you make the grouping, for example, you want to group, so over here you have 1x11, so you can form a group over here. So that's why you have a green color over here. And over here you have 1, and over here it can be 0, it can be 1, so you can have another group over here. So our overlapping group over here. So this one, because this x you take as the value as 1. But however, over here, since it is alone, and it cannot be forming anything with number 1 of any side of it, because you don't have a connection here, you don't have a connection here, you don't have connection here, and also here, top, bottom, right, and left. So therefore you take this as 0 and you just need to make the k-map of this one. So that's why for this particular green you have a dot b bar. So here you can eliminate C and D. So that's why you have a dot a bar b bar. And for the yellow, A, you just keep the A, B can you eliminate, and C bar and D, so C bar and D. That's why you have the final SOP, minimized SOP will be these results. So self-check 2. So try to obtain the simplest SOP using the K-map method. And then you need to also explain why certain X are not used. And then this is the answer for your help to help you out. And this is the truth table. So please, this is a little challenging, so I hope you can finish up this one. And please continue to the document 3.7 universal of none and nor. And see you again. Bye.